Yes, sir, you are live now. Please tell.
All right. Hello, everybody. It's a pleasure to thank you. Hi, everyone. It's a pleasure to uh, welcome you for this third and final live interactive session for our course, a basic course in number theory. So I see that Kashi Garuji has already asked some things, so I will be happy to explain. So let me start with exam pattern. I think exam pattern is something that people would want to know even after 15 or 20 more minutes, but I will explain it again. So yeah, I am always happy to talk about these things. Thank you, Satindarji. Good morning to you also. So Kashina Dhanuji, you have, I will first talk about the second suggestion, requesting to reduce the multiple choices from 6 to 4. Yeah, maybe I could think about it from the next course onwards, because you know the exam pattern is already fixed, and if there are 6 multiple choices given already, then I cannot change them now. But let me tell you about the exam pattern. So you know, exam is for 100 marks, and it is divided into 4 parts, meaning there are questions of 4 types. So 10 marks for 1 mark question. So there will be a very simple questions which you should be able to answer in the yes or no, or some very true or false, or some very easy calculations. Good morning, Krishna Gopalji. So those will be the questions for which there are 10 such questions for 1 mark each. So we have 10 marks for that. Then there are 10 questions which are 2 marks each. So these are questions which require some small calculation. This calculation can be computing quadratic reciprocity of a given number for a certain prime, or asking whether something is reduced, some binary quadratic form is reduced. These kind of questions. These are there, which are 10 many. So 10 questions for 2 marks, that gives you 20 marks. Then there are some questions which require a little more calculations. So those will be for 3 marks each. So 10 questions for 3 marks again. These are calculations which will be slightly more involved. Okay, so you have 10 marks for 1 mark questions, which are 10 in number, 2 mark questions, which are also 10 in number, 3 mark questions, which are also 10 in number. So you have accounted for 10, 20, 30. So in all, we have accounted for 60 marks. Now the last 40 marks. These are distributed over 4 questions of 10 marks each. These 4 questions will start with defining a certain problem, and it ends with the complete solution of that problem. So these can be some, you know, meaning it can require some calculations to be done using the Chinese remainder theorem, in addition to some calculation to be done using the quadratic reciprocity law, and so on. So these will be long questions which will be worth 10 marks, and each small calculation in that will account for 1 mark or half a mark. So as you go solving these questions, you know, meaning the questions towards the fag end of the course, where you had to do lot of calculations, those are the ones which are really coming for these 10 marks. But each calculation that you do in that will have partial credit. Okay, so I'm not saying that, you know, I cannot disclose the questions, but I cannot define a problem and give 10 marks for the final answers. That is not what I have done. I have given marks for each of the intermediate steps. There can be 10 steps, there can be 15 steps, each small calculation, and which each of those calculations will be roughly for 1 minute or 1.5 minutes. And so once you are done with that, I think, you know, 10 or 15 minutes will be enough to solve this one question of 10 marks. So if you know, really think about these things, the exam, I believe, is for 3 hours, but within 2 hours or 2 hours and 10 minutes, you should be able to solve this whole exam. There will be calculators which will be provided. The calculators will be scientific calculators, but of course you won't have to require, you will not require sine cos or tan of any number, but you can take squares, square roots, those things will be there in the calculator. So those are the calculators which are given to you, and these are the question patterns. What NPTEL has told me is that they shuffle these questions. So I have given you the questions which are 1 mark 10 questions, 2 mark 10 questions, 3 mark 10 questions, and then 10 mark 4 questions. So there are 34 questions in all. So these 34 questions are shuffled by NPTEL. So you may see a 1 mark question, then a 3 mark question, and Sahaji, good morning. And maybe then a 10 mark question which will be long, and then again maybe some 2 mark questions. So those things will keep coming. If you want, you can just go on and do all the 1 mark questions first, then all 2 mark questions, because 1 mark questions will take less time, then 2 mark questions, and so on, and in the end you may want to return to the 10 mark questions. So this is the pattern of the exam. Good morning, brother. So it's very nice to have you, and the course is now coming to an end. I hope everybody has enjoyed this course. If you had any particular question about so Bapiji, it will not be a pen paper exam. There will be some terminals which will be given, because there are thousands of students who have registered for the course, and a few hundreds have registered for the exam also. So grading this will be very difficult. So it is not going to be a pen and paper exam. It will be an online exam to be done on a computer, and you have to. So the questions that I said, the last four questions of 10 marks, there you will have to compute an answer and you will have to enter that number. Okay, so but that is again to be done by a computer. So it will not always be a multiple choice question. Somewhere you will also have to do calculations and enter the marks. Okay, so Umaji, yes, I think you had also written an email to me, but I did not reply to you. So there are books which I think I have already mentioned on the NPTEL webpage, the course webpage. Those are very good books. And then there are some basic books on number theory, but meaning typically what happens is that we should stick to one book or two books for some courses, so that the pattern and so on can be understood. So there is the book by Baker, which is already there, and I think there is the book by Burton, which I have put on the course webpage. So those are the elementary number theory book by Burton, I guess. So those are the books which we will be using for this course. I think it is better to stick to these books. Once this course is over, then please write to me if you want to study further, and I'll be happy to give you any further suggestions. I may also announce this time that I am thinking of having a further course on number theory. So maybe in a few years time we will come with this another course, and it would be very nice to have you all for those courses. So there is a book by Niven and Zuckerman which I have suggested on the course webpage, which is also a good book. So right now let's stick to these two books, and then we will see what else to do later. But have a good practice. This is a very basic course, but in the sense that it doesn't require too much prerequisite, meaning there is some group theory which we have used. But in today's world, if you want to do any mathematics, any good mathematics, I think you cannot do it without using some basic group theory. Like real analysis is something, complex numbers is something that we all know, real numbers is something that we all know, basic integers is something that we all know. So similarly, group theory, very minimal group theory, finite groups, that is something also that we should maybe brush up with. And I hope you have enjoyed this course. So we will perhaps follow it up with another similar course, but slightly advanced, where we will really go into number theory, and then maybe we will see what to do. So, all right. So, Kashina Dhanuji had also suggested to reduce multiple choices from 6 to 4. So, certainly, Umaji, you can mail me after this course, and we can discuss more about number theory. It will be a pleasure to explain these things. Right. So multiple choices from 6 to 4 is something that I will certainly think about. Maybe from next year onwards, for this course also and also for the exam, I will not give 6 choices, but I will give 4 choices. So indeed, Kashina Dhanuji, the last 4 questions, which are the 10-mark questions, they are not multiple choice. They are long questions. You will have to do lot of calculations, and each calculation will have some credit, maybe 1 mark, 2 marks. Some final answer will have 2 marks, maybe, and 1 mark for one some intermediate step. If it's a small calculation, then there will be half a mark. But these answers for all these calculations will have to be written in the form which is provided. There will be a blank space, and in that blank space, the answers will have to be written. So it is not multiple choice. First 3 parts, which is for 1 mark, 2 mark, and 3 mark, they are multiple choice. And again, it's the same strategy that you have to choose all correct answers, right? Because there is no intermediate way of doing it. So this is what we have. Thank you, Bapiji, for your kind words. It means a lot. All right, so I will maybe just wait for some time to see if there are any other suggestions or questions, or I'll keep talking about some interesting mathematics. Recently, a lot has happened in number theory. Many interesting questions are being studied. Several people have been continuing to work. Lots of good Indian mathematicians have done good work. So I hope you are looking forward to studying number theory further. I may also tell you that an institute has come up in Mumbai, which is called Lodha Institute, and for mathematical sciences, and they are having thematic programs. So for this semester, there is a theme of counting in number theory, and Professor Manjul Bhargav will be present, I think, for most of the part. And please check out the link of Lodha Institute, and you will be able to see the lectures that they are giving. I think they also have a YouTube channel. So some lectures will also be streamed live. So you will be able to see them. Many interesting things are happening in India about mathematics. I hope you will continue doing number theory or mathematics in some sense, and it would also be a pleasure to meet you sometime. You know, I have met some of my previous students from these courses, and it's always a pleasure. Some people have come to IIT Bombay for some reasons, and then they wrote to me, and we decided to meet. So that was very nice. Of course, I also go to many places in India and give lectures and so on. So wherever I go, if you happen to be around, it would be a pleasure to see you also. So this time in the Google Sheet, there were not many questions asked by people, but I hope that people will come here with some questions and we can have a good discussion. One thing am really proud of is that there are no mistakes in solutions or problems this time. It has happened once or twice in the past, and it's then we have to cancel some question, etc. Right. So yeah, so in assignment 9 we had some questions on three smallest non-zero values represented by the quadratic form. For this type of problem, how can we solve? So actually I have done a result. If you have a reduced binary form, which is of the form say ax square plus bxy plus cy square, then we know how A, B, and C are ordered, meaning A is less equal C, B is between minus A and A. So those are the things that we have seen. So whenever we have a form like this, ax square plus bxy plus cy square, the smallest three numbers, there is a formula to write them down. you can put x equal to 1, y equal to 0. So that will give you a. And many cases, a is the smallest number which you have. So in the book of Baker and also in my lectures, I have given explicit formula for computing these numbers. So whenever you have a reduced form, this is only there for the reduced forms. Otherwise, if you have a non-reduced form, you will have to reduce it. And once you reduce this, then you will be able to compute this small number. So please look at the lectures. I think there are maybe only 4 or 5 lectures which I have given on the binary quadratic forms. So there you will see the formula for writing the smallest non-zero values. Because of course, if you put x equal to y equal to 0, then 0 is represented. But other than 0, you can put y equal to 0 and x equal to 1. So I guess the values are really achieved at 1 comma 0, 0 comma 1 and 1 comma 1. So the simplest possible values that you can think of, those are the values which are the smallest non-zero values. Sometime it may happen that a is equal to c. In that case, you will have to do some more calculations and get the next number. But again, once you are given the multiple choices, now so first of all, although we may have several correct answers, but it's clear that from this question, there will be only one correct answer, right? So given among the given options, you have to see which option is the correct option. Some numbers can be easily read off from the given binary quadratic form. You will immediately see that this number is represented. If you put x equal to 2, for instance, and y equal to 0, 4a will be a number which will be represented by the form. But then again, 3a or just a is also represented because you can put x equal to 1. So you will be able to see how some numbers can be seen to be represented by the form. And if there are some options given in the question which are smaller than the numbers you have come up with, then you have to just verify whether those numbers are represented by the given form. So I think in one of the exams, in one of the assignment questions, I remember it was somewhat work to show that 3 is not represented by the form. And once you see that 3 is not represented, then immediately you have an answer for that. Okay. Right. So that will solve. Similarly, if your question is negative definite, then you multiply all numbers, all coefficients by -1. You get a positive definite reduced form. Then you have its 3 non-zero smallest values. Multiplying those again with the -1, you will be able to see the 3 largest non-zero values represented by that negative definite form. So it can be solved in that way. But I think in the exam there are no negative definite forms. Krishna Gopalji has asked assignment 10, question 10. So let me go to the assignment and see if it is anything difficult. Right, assignment 10. Assignment 10 is on okay, which of these rational numbers give a good approximation to square root 17? Okay. So in fact, we have seen some result which said that so actually I will have to check whether these numbers are also the convergents to the number square root 17, but we just have to apply the definition here. So square root 17, p by q gives a good approximation to square root 17, provided square root 17 minus p by q, the modulus is less than 1 upon q square. So that's all that you need to do. So for D, for instance, 268 minus 65, 268 upon 65, you have to compute the number and you can use a calculator for this, right? So you compute square root 17 minus 268 upon 65, multiply this by 65 square and see if you get something which is less than 1 in the modulus. All you need to find is root 17 minus 268 upon 65 in the modulus is less than 1 upon 65 square. This is the only thing you have to check. So you can just multiply by, you can do all calculations at one go. Compute the difference, square root 17 minus 268 upon 65. It will be some number positive or negative. Multiply to that by 65 square right away. And then see whether you get a number which is 0 point something something with a negative sign or a positive sign. That is all that you have to check. So for each of these numbers, this is something which may come for 2 marks or 3 marks. A question like this in the final exam will come for 2 marks or 3 marks. But actually this is simple calculation, and meaning computing these things, just doing it on the calculator and maybe doing it once to check that you have got the correct answer should not be difficult. I hope that answers question of Krishna Gopalji. So Isha ji has asked whether there is a conference or seminar you would suggest for us to attend for higher studies. So yeah, there can be several conferences and seminars which you can attend. So one will have to see where you are presently, and in your neighborhood you should look for some such thing happening. There are many universities, I think, which are which have good mathematics department. So you may go and talk with mathematicians there. That way you will get to know if there are things happening nearby. Okay, then there are some best institutes around the whole country. There are good IITs. Then there is the Institute for Mathematical Sciences in Chennai. There is a Chennai Mathematical Institute. As you come up, there is the Indian Institute of Science, IISc, which is in Bengaluru. Then there is TIFR, Tata Institute of Fundamental Research in Mumbai. And there is the HRI, Harishchandra Research Institute at Prayagraj. So these are institutes which are devoted specifically. Of course, IISc has some teaching programs also, but the other institutes are devoted specifically to research. So there are lots of conferences and seminars happening there. So you can look at their web pages, and that way you will come to know about the conferences. In addition, there are these Indian Statistical Institutes. I think there is a campus in Bengaluru, there is a campus in Delhi, and one in Kolkata. They also organize several things. Then there are the good IITs, my IIT, IIT Bombay, IIT Kanpur, IIT Delhi, IIT Madras, IIT Kharagpur, and Guwahati. These are the main IITs. Then there is IIT Roorkee and many other IITs. Each state has an IIT. So all these IITs also combine to have lots of things. In fact, I would say that there are many things happening around, and you will be able, if you check some of these web pages, you should also try to see which things interest you more. If number theory is the thing which interests you more, then you should look at people working in number theory, and then you will be able to see conferences or seminars, because these people would visit and attend those conferences or give lectures there. So that is how you will be able to go. At top of my mind, I cannot suggest anything, because again it depends a lot on your interests and what you really would want to study. So this is what I would want to say for the moment for Isha ji's question. And I hope Krishna Gopalji has got an answer for his question. That was an interesting comment that he made about assignment 10. So we could also discuss assignment 11 today, because I believe that its due date is past. The assignment 12 is yet to be submitted, so unfortunately I will not be able to discuss that one today. But all the other assignments we can discuss, and if you have any question about it, I will be happy to answer. You are welcome, Isha ji. There is one more thing which I should perhaps tell you, because the marking system. So we have had several assignments, and what NPTEL does, to the best of my knowledge, is that it will take your top 8 scores. It can happen that you have not done well in some assignment particularly. So if you have not done in some assignment particularly, but you have done better in many others, the NPTEL will take only those better scores. So the top 8 scores out of the 12 assignments, they are taken. They, I think, then that marks are considered converted to marks out of 40, perhaps. and the final exam score is converted out of 60, and then that combined will give you the your grade. So your work done for the assignments will also not go unaccounted for. That will be accounted for, and you will get credit for that in the final score. On the other hand, if you have not done well in the assignments and you want to make up for that, then you have a chance in the final exam, which is out of 60. You will be able, you can work hard and do well, and then you will be able to get it. So assignment, Umaji has asked, assignment 11 question 3, we have to check all the options separately. So yeah, let me see what is assignment 11 question 3. Which of the following numbers have 7 by 6 as a convergent, right? So this was a somewhat like a converse question, right? Meaning the previous question asked which of the rational numbers are convergent to the given number, which is 13579 upon 2468. Here the question is somewhat converse. What you need to do, first of all, it is to write the continued fraction expansion for 7 by 6. Okay, and then you have to get the continued fraction expansion excuse me, for the remaining, for the given options, and see if this continued fraction expansion comes in that continued fraction expansion, right? Meaning if your number is convergent for some number, then it would mean that its continued fraction expansion should be a part of the given number's continued fraction expansion and starting from the beginning. So that is the thing that when we'll have to ask. So Bapiji, you, all questions in the exam are not of multiple choice category. There are four parts. There are four types of questions. There are questions which are for 1 mark, and they will be of the type true or false. There are questions which are for 2 marks, which will be some simple calculations. There are things for 3 marks, which will be little more calculations. And then there are four questions of 10 marks where you have to do the calculation. So the first three are multiple choice, first three types. And the last, which is the 10-mark question, it will have several steps. And in each step, you will do some computation, and that answer you have to key in. You will have to, if the answer is say 135, then in the computer you have to go to that blank and write 135 as your answer. Oh, Krishna Gopalji says that he computed only convergence and got one answer, but the other answer is also an accepted answer. Yeah, right. That can happen. Yeah, meaning, this course is something where I cannot ask theoretical questions because I do not have resources to grade all your answers. But if this interests you, then there are other courses which we will soon have, and in these courses you will be able to see more of theoretical part, where more theory will be seen. But unfortunately, this time we could do only calculations in the assignments. But let us see, perhaps in some other times I could interest more things. I could have more things. Very well. I think many people have asked their questions, and I will go through all the questions once again to see if I have missed anything. So Umaji has asked whether she can mail me to know more. Certainly, you can email me and I'll answer. Right. So I think I have answered almost all the questions which are asked here, and there was a Google sheet which was shared with you, and nobody has asked any serious question there. Many people have made some comments, but no serious question was asked. So I hope everybody has understood everything that is here. All right, Umaji has asked 7 by 6 is 1/6 and 169 by 144. Okay, but how do I do the calculation now? Now it will be so difficult to do it. Yeah, so, all right. Hmm. Okay, the question was 7 by 6. So 7 by 6 is, we know it is 1 plus 1 upon 6. And so sometime what happens is that, this one, the last number, which is 6, can be also seen as 5 plus 1. So another way to see 7 by 6 is 151, and maybe that is the one which is being used here. So that one will have to see, right? So one may have to use some clever way to look at these numbers. That might be the reason. Assignment 11, question 3, 169 by 144 is the second option, right? 169 by 144 is very much there. So right, I think 159, 169 by 144 is 15136. 169 upon 144 in the continued fraction expansion is 15136. And therefore, the first three numbers, which are 151, account for 7 by 6. So that is what it is. So although, meaning I said that you have to compute the continued fraction expansion of 7 by 6 and see if it occurs in the continued fraction expansion of the given numbers. But when you have a rational number, there are two possibilities for the continued fraction expansions. And here both the possibilities are used. So 1 comma 6 is one and 151 is the other. So that is the one which will be used. So I hope that answers Umaji's question and also Satinder's comment. Krishna Gopalji has asked, for studying cryptography, is this course enough or we should study more advanced number theory course? So typically for, yeah, indeed. Thank you, Umaji. So for cryptography, there is something called this classical cryptography, for which only the numbers like modular representation, modular arithmetic will be used. But often cryptography goes into higher domains, advanced domains, for which you will need to know elliptic curves. So elliptic curves will be perhaps done not by us in any of these immediate courses, but you can see some online lectures. I think I have also given some online lecture on elliptic curves. It can be found on YouTube, or there are many other lectures which are given on elliptic curves, so they will be also there. So our course will be useful for studying cryptography, but you will need to learn a lot more. Immediately from this course, you cannot go directly into doing cryptography. That's the thing. Right. Good. I am happy that you have asked some, particular questions, and I'm even more happy that I have been able to answer. Typically when we have 10 questions per assignment with several options per question, that's a lot of calculations. and getting all those calculations correct is important, but also to reproduce them is not so easy. All right, Satinder ji has asked a question. To know the primitive root of a particular number, you have to check by Legendre symbol. What we have to use the format theorem only. Is there any relation for the quadratic residue primitive root? So, first of all, given a number, you should be able to write its prime factorization. This is something you should be able to do immediately, meaning, however big the number is, the number in the exams, the numbers which have come are not bigger than 3-digit numbers. So, even for 3-digit numbers, you should be able to write the prime factorization. Once you write the prime factorization, then you will immediately know whether the number has a primitive root. Every number will not have a primitive root. That is because if n is the number, you are looking at un, the integers which are co-prime to n, and therefore they are invertible, so that forms a group. Each such group is not a cyclic group. For instance, if you have two odd prime factors, then 2 will divide with multiplicity 2, and so one knows that this is not going to be a cyclic group, because there will be more than 2 square roots of 1. Okay, so therefore you will not be able to have a primitive root for that. Padnar is wondering why this is being live streamed. How else could I answer questions which are asked here? Meaning only the live streaming can answer the questions, right, which are asked here. So coming back to Satinder ji's thing, so once you know whether some number is a primitive root, then you will have to compute it. Now again, Legendre symbol will only be able to help you in telling which numbers are squares. So if a number is a square, that cannot be a primitive root because it has a square root. So normally we don't really have to go to Legendre symbol computation to check whether some number has a primitive root. The primitive roots are computed in a different way. I think even while we have done this course, the quadratic reciprocity law comes after primitive roots, right? So primitive root was something where we studied how the numbers, the groups un look like, and after that we went to the quadratic reciprocity law. So quadratic reciprocity law is something to be done after. The Legendre symbols are not really very useful in computing the primitive roots. Sometimes we have to just, sit down and do the dirty work with hands, do all the calculations to find the primitive roots. That is what we will have to do. Right. So I see that there were many themes which we have learned in this course. We started with, prime numbers, which is really the basic part of number theory. Then we went to modular arithmetic. After modular arithmetic, we went to quadratic reciprocity law. Then from quadratic reciprocity law, we went to the binary quadratic forms, and ultimately we learned continued fractions. So those were the 5 themes. We also learnt about Pell's equation and interesting ways to look at them. There were interesting things about the number fields, the units in those number fields. So quite a lot of number theory is already done in this course, and I hope this will help you studying further the other parts of number theory. Once again, I would like to announce that I am thinking of having another follow-up course after this, where we will see some more advanced parts of number theory. And but that course, meaning it will take some time for to formulate the course and to have it up and running. But meaning if the mailing lists are available even then I'll inform once this course is up and running, and then you will be able to see whether you have time to join those courses. So those are the things that we have for future. It's already 11:20. If there are, I will maybe wait for 1 or 2 minutes. If there are no further questions, then we will stop this live session. So if you have any question, please ask the question now. There is no better time than now to ask questions. Satinderji is asking very interesting questions. Is there any easy method for prime factorization apart from square root test? Elliptic curve method also give the factorization. Messenger toughest problem part is the prime factorization. Prime factorization is the most difficult part. Meaning when I say this, that prime factorization is the most difficult part, I mean this for all numbers, meaning there are two things. In our exam, we will have some numbers and we will have to do prime factorization for them. That will typically be not very tough because I would not want you to spend half an hour factoring one particular particular integer into primes. But in general, if you are given any numbers, meaning typical thing is to look at the numbers which are of the form PQ, and you will also know P minus 1 into Q minus 1, but getting P and Q from them, that will be the most difficult part. So there is something called as public key cryptography. That is the part where the key to encrypt a message is announced publicly, but the key to decrypt the message will be only for with very few people, and therefore everybody will not be able to decrypt, because factoring a given number is not an easy thing. Even some high level computers can take days to factor a given number. So therefore, indeed, as Satinderji has said, there are several methods, although also Agrawal and others, Manindra Agrawal, Professor Manindra Agrawal, who is right now director of IIT Kanpur, he and two of his students, they have proved that polynom primes is a polynomial. There is a polynomial time algorithm to factor them, but it takes too much time. So there are some ad hoc algorithms which take less time, but even that less time is too much for the computers. So indeed, encrypting is possible, and we would want to have things encrypted, right? Meaning, we don't want to have things which are which can be decrypted. For instance, there are other ways. So I mentioned elliptic curves. So in the elliptic curve, you can have some number and take its, meaning given A, B, and C. You can see whether C is equal to A power B. Given A and given B, you can find A power B and therefore check whether C is A power B. Given uh, B and C, you can also check, although it will take some time, whether A power B is C. You can find the bth root many times. You can find the bth power many times. But it is difficult to find the number B given A and C. Which power is that number C? That is very difficult. So typically, whenever you have several such numbers and several operations involved, some operations will be easier to do and some operations will not be easier to do. And encryption, decryption, the whole cryptography depends on the difficulty of those operations. So, right. So there are no easy methods for prime factorization. All right, I will wait for 1 or 2 minutes. Otherwise, we will call it a day. And I will wish you all very best for the final examination. I hope that many of you write it. I see at the beginning works in number theory in India. Yeah, so there are some mathematicians who are doing excellent work. So in ISI Kolkata, there is a mathematician by name Ritabrata Munshi, who is a wonderful mathematician, and he is working at the cutting edge of analytic number theory. He is working on Riemann hypothesis and several such things to do with L functions and so on. Another mathematician who is at Bengaluru right now, his name is Mahesh Kakade. He is doing what can roughly be called algebraic number theory. So Galois representations and so on. And there was actually a conference which was focused only on the work done by Mahesh Kakade. So he is another very interesting mathematician. So these are two of the young people who are doing very good work. And in addition, there are several other people. You know, Ramanujan has always been an inspiration for many of us, and there are many people who continue to do Ramanujan type of work. So I guess there are some, I don't remember the name right now, but there is somebody in IIT Gandhinagar who also does this work. So yeah, we are doing quite well at the moment. Okay, I think back end, I will request you to stop the session now. It's 11:26. We are close to the time. And anybody else who has any other question can write me an email and I will try my best to reply. Thank you very much for joining.
Thank you, sir. We will stop now.